So we have seen number systems. So a few number systems are decimal, used by us widely, binary, octal, hexadecimal, right? So how these are differentiated based on the radix, or we call it as base, right? So the base of decimal number system is 10. It means it is using 10 distinct symbols to represent any numbers, right? So what are those? Those range from 0, 1 to 9, right? 5, 6, 7, 8, 9. 0 to 9. Coming to binary, its radix or base is 2. So it is using only 2 symbols, zeros or 1 for representing any number. Coming to octal, it is radix or base is 8. So it is using 8 distinct symbols range from 0 to 7 for representing any number. Hexadecimal base is 16. So it is using 16 distinct symbols. 5, 6, 7, 8, 9, and then A, B, C, D, E, and F, right? And so how a number is represented in any of these 4 forms, and the conversion between any of the systems is also known to you, right? So we can use powers of base to convert back to your decimal number from any other number system. And we can use a divider and remainder method for converting a particular number system to any other number system. Am I right? Okay. So, and that procedure, I feel that it is clear to you. And apart from this, another widely used is BCD. What is BCD? BCD format of
Binary coded
representation.
decimal.
Yeah, binary coded decimal. So here it is nothing but decimal. The numbers are in decimal, but they are represented in binary format. Okay. See, for example, if a number is 19 or 29, so the corresponding BCD number is, what is the corresponding BCD of 29? Binary coded
0010
0010
1001.
1001. Okay. So if the same thing, if I want to represent in binary, what is its corresponding number? Binary. $29 in decimal. I want it to represent in binary. So it is how much? 16 plus 14.
1
16 plus 8 plus 4 plus 1, right? 1 1 0 0 1 0 1.
1 1
Am I
0
right?
1.
Right? So this is in binary. Okay, but this is in BCD. Okay, so there is a difference here. So though they are using only zeros and ones, but this is BCD format and this is binary format. BCD means it is using only the decimal numbers from 0 to 9, but they are represented in binary. Okay, digits wise it will represent. And what is its corresponding number in octal? To get octal number, we will group 3 bits together from least significant bit onwards. Okay, so this is 5 and this is 6.
6.
So 65 in octal. And corresponding number in hex.
Ma'am,
Yes.
binary number is wrong. It's 11101.
1. Oh, is this 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Yeah. 2 power 0, 1, 2, 3, 4. 16 plus 8 plus 4 plus 1. Correct? So now my octal number is 35. Am I correct? Now, is it fine?
Yes, ma'am.
35 and the corresponding number in hexadecimal, you have to group 4 bits together, and the upper 4 bits, we have only 1 bit. So remaining 3 will be 0. So 0, 0, 0, 1. And this is 1101 means 1101
C.
D 1100 is C. Okay, 12. This is 13. 1D. 16 plus 13. 29. Okay. So this is corresponding in the hexadecimal. Okay. And another number system is alphanumeric, what we call ASCII version, widely used in computers, because we won't not only work with just numbers, we also work with the text characters. Okay, so whatever it is, the character is also have to be stored in a memory in binary only. Okay, so that ASCII formats are used for that. Okay, so apart from this, anyway, these are in number systems. Now our number, whatever it is, the number that you have to represent it in binary when we work with the computer. Okay, so now what are the types of numbers that we may come across in our day-to-day life for your particular applications, right? Numbers can be, first of all, it can be positive or negative, right? And numbers can be integers or fractionals or mixed integer fractions, right? So possible, our numbers may belongs to any of our mixed categories, right? So now you should be able to represent all these numbers in corresponding binary only, corresponding zeros and only, zeros and one only, right? Now there are methods to represent these numbers in binary. Those are, there are 2 ways. That is what called fixed point representation and floating point representation. Okay. So before going to this, I wanted to explain another thing. That's what. So first of all, we talk about sign. After that, we move to integer or fractional part. Okay. So how a sign, how a number, if my number is positive and or if my number is negative, how we represent that sign finally in your computer. Okay. So our numbers can be positive or negative. Okay. See, there are 2 types. We call them as unsigned and signed numbers. Okay. So what is the difference? Unsigned numbers means unsigned numbers.
They will always have a positive.
They doesn't have any sign. We treat all the numbers as positive. Signed numbers, they have a sign in it. Okay, numbers can be positive or negative. Okay, right? So how to see, when we humans are working with the help of pen and paper with the numbers, the size of the number, it doesn't matter. He can extend to write continuously because he himself is writing with pen and paper, right? So but when we want to store the same number in your computer, there are certain constraints. Okay, so constraints related to the size of the number, maximum number that we can store into your memory location or register corresponding to that particular CPU. Okay, so what is the maximum and minimum range when we talk about a particular computer? So that is usually deals with the data bus capability of your computer and also the processing capability and of course the size of the register. Okay, how many number of bits my register can store. Okay, see, for example, whenever you say how many bit processor that you are working, I can say that My processor is 64-bit processor, 32-bit processor, right? Likewise, we will say. So what it means? A 32-bit processor means what? Can anybody say?
The number of digits in a number is 32
Yeah.
bits.
32 bits. So my processor is capable of operate on 32 bits at a time. It could able to read 32-bit data at a time. It could able to process 32-bit data at a time. It could able to store 32-bit data at a time. That's what a 32-bit processor meant for. Similarly, 64-bit. The data bus width, the registers, and the processing capability, everything are of 64-bit. Okay, right? So accordingly, the maximum and minimum range of the numbers will be varied. So as the number of bits are more, then the dynamic range is more, right? So the maximum and minimum number that we can represent is large. So my computer is capable of performing that many operations. Okay, right? So let us talk with just simple 8-bit numbers first. After that, we move to 16 and similar conversion process. Okay. So when I talk about 8-bit size, what is the minimum and maximum number that we can represent with 8 bits? Minimum number? And I'm talking about
All zeros.
unsigned. So unsigned numbers, there is no sign concept here. So all digits, all bits are used for representing the magnitude of the number. Am I clear? Magnitude that specifies the value of your number. Okay. All bits are used for specifying the magnitude. So minimum, all, if I take a minimum value out of 0 and 1, 0 is the minimum. So I'm taking all the bits for 0. All the bits as 0. So this gives us a 0 in decimal, right? So when we come for maximum number that I can represent, so all the bits I
All
can
ones.
take a maximum value. So in binary, out of 0 and 1, 1 is the maximum. So I'm replacing all the bits with 1. With this, what is the value that we can represent in decimal? In decimal, what is its corresponding value?
2 power 9 minus 511.
Yeah. No. 2 power 8 minus 1, because it starts with 2 power 0, 2 power 1, 0 to 7 bits. Totally 8 bits, right?
255.
Yeah, 255. 2 power 8 minus 1, 255. Right? This is the minimum and maximum in case of 8-bit unsigned dynamic range. For 16-bit, it varies from 0 to 2 power 15 minus 1. For 32 bits, 0 to 2 power 31 minus 1. Likewise, it extends, right? So all the bits here are used for specifying the magnitude only. In unsigned case, there is no concept of negative, but we know that our numbers may also be negative, right? So how to represent a negative number in a computer? How to store that symbol minus and a symbol positive in a computer? Okay. So to store the sign of a particular number, so universally they follow one particular notation which says that the most significant bit of a particular number represent the sign of the number. Okay. So most significant bit of a number represent the sign, and for positive numbers, the sign bit is 0, right? And for negative numbers, the sign bit is 1. Okay, right? And the remaining bits, after separating the most significant bit, the remaining bits are used to specify the magnitude of the number. Okay, so if I take the same 8-bit size, 1 bit I am dedicating for sign bit, and the remaining 7 bits are only available to represent the magnitude, right? So with this, the range, the minimum and maximum values that we can represent is obviously varied. It is not just 0 to 255, right? Am I right? Okay.
Yes, ma'am.
Right. So how these 7 bits now are used for representing the magnitude, to represent that, there are again, there are 3 ways. Okay, 3 different ways are used to represent the magnitude of a particular number. One format is sign magnitude form, and other is, can anybody say remaining 2? One's complement form,
Or 2's complement.
one's complement, and 2's complement notation. First complement, second complement. Okay, I feel you know how to calculate ones and 2's complement of a particular number. Say yes or
Yes,
no.
ma'am. For my
Okay, so you how to calculate one's complement of a number?
Or replacing
Complement
1
A.
with 0.
Yeah, you have to replace 1 by 0, 0 by 1. Then I'll be getting 1's complement of it. Next, second complement, 2's complement.
Adding 1 to the
And one.
LS bit.
After calculating 1's complement, you have to add 1 to the result to obtain its 2's complement value. Right? So there are 3 possible ways available for representing a negative number. Okay, negative number. Okay, right? Out of these 3, you need to go with the best one, right? So which is the best one out of these 3? And first of all, what is sign magnitude form of representing a number? See, for example, let us consider 29, minus 29, I want to represent in first form, sign magnitude form. Let us consider sign magnitude form. We know how 29 is represented. Just now we have calculated, right? 29 is
11101.
11101. 11101. Okay. So while representing this, you need to first fix how many number of bits that you are saving your number. Okay, you are using to save your number. Okay, so we are all talking about now 8-bit. So these are how many bits? Only 5 bits. So what are all the remaining 3 bits that you need to append with 0? Now this becomes the total 8-bit number. Okay, this is 8-bit number, and I want to represent minus 29, out of which, so in sign magnitude form, the sign bit is separated. This is the most significant bit used for representing the sign, and the remaining 7 bits are used for representing the magnitude. Okay, so this is hence the sign. So this will become 1 since my number is negative. Minus 29 I want to represent. So this says that the number is negative, and this gives the magnitude. This is what sign magnitude form. Okay, so it is magnitude, simple. 2 powers, if you apply, then I'll be getting 29. Since my sign bit is 1, so the number is minus. Just a minute. Okay, sorry, this is minus 20. Similarly, if I want to represent, let us suppose simple case, plus 9. Okay, so plus 9, most significant bit is 0 because the sign is positive, and the number 0, 0, 0, 1, 0, 0, 1, plus 9. Okay, similarly, if I want to represent minus 31, minus 31, how can I do? Minus. So most significant bit should be 1 and 31. 31, 2 power 5 minus 1, right? So 0, 0, 1, 1, 1, 1, 1. Am I right? Is it clear?
Yes,
ma'am.
Sign magnitude form. This is how we can represent any number in sign magnitude form, whether it is positive or negative. Okay. So with this, what is the minimum number that I can represent in sign magnitude form? Minimum.
minus 127.
Minimum, so their negatives always will be the lesser when compared to positive. So my most significant bit should be 1, right? Am I clear? This is
Yes, ma'am.
sign bit is 1, and coming to the magnitude, see, if for any negative number, if the magnitude is high, that negative number is the minimum, right? Am I clear? If the magnitude is
Yes, ma'am.
less, the negative number is out of all negative, that will be the bigger one, right? So now I have to take a magnitude high, so that when I add negative to that, then that will become the minimum out of all the negative numbers. Am I clear? So what should be
Yes,
the
ma'am.
magnitude bits?
all ones.
All ones.
All ones. Okay. Because minus 7 is bigger than minus 1. So whichever is having the magnitude high, that number is the minimum number. That's why our 7 bits will be 1. So what is its value in decimal? Sign bit is 1, so it is minus, and 7 bits are 1. So apply the 2 powers, we'll be getting 2 power 6.
127.
How much? 127.
7.
127. Okay. And what is the maximum?
Plus 127.
0, and all should be 1. Okay. So it is plus 127. So this is the maximum. Right? Okay. So the range of numbers that I can represent with 8-bit size in sign magnitude form is minus 127 to plus 127. Okay. Right? So, but here there are 2 disadvantages in sign magnitude form. One is, see, whenever you have numbers, whenever you want to perform operations on 2 numbers, you need to treat the sign bit separately, right? This should not include while performing the operations, right? Only the magnitudes have to be performed, right? Either addition or multiplication or subtraction. The magnitudes have to be undergone for operation, and the sign bits need to be treated separately. Am I right? Because sign,
Yes, ma'am.
it represents only the sign of the number. It is not related to, nowhere related to magnitude. So we should separate the sign bit from the total number, and then the remaining magnitude bits have to be undergone for operation. Okay. So 8 bits are stored in any register or memory, but while working, you have to separate the sign and magnitude and then proceed. Okay. And the second is disadvantage. See, if I come for 0, okay, 0, positive 0, what is its notation? Positive 0.
All
My
zeros.
sign 0 and 7 are zeros, right? This is positive 0. And what is minus 0? Negative 0. Sign is 1 and these are zeros. Okay. See, but as per our interpretation, either positive 0 or negative 0, it is just 0. Okay. But here, the same number which is 0 have 2 different representations. Okay, so this is one of the very important parameter to be considered. Any number should have only one and only one representation in its corresponding form. Okay, but for 0 we have two representations. There is a chance of getting +0 or -0 as an output. Then there will be a difficult for the computer to decide whether it is +0 or -0, plus value or minus value. Okay, so no number should have more than one representation in its form. If it is there, then it is not a correct way of representing the numbers. Okay, so this is the biggest disadvantage in sign magnitude form. So hence we are not using this method of saving the numbers in computers. Okay, right? So first disadvantage, need to separate the sign from the magnitude and you need to proceed. And second, since 0 is having more than one representation, so it is difficult for the computer to decide whether it is +0 or -0. Okay, so this is about the sign magnitude form. Is it clear?
Yes, ma'am.
Yes, ma'am.
Now going to the second, which is one's complement. One's complement here. So to represent any number, we will represent it, treat that first in binary, and then we complement the number, one's complement, to have its corresponding negative number. Okay, right? So if I want to represent -21, first write what is +29. Okay, sorry, +29. So what is +29? 0, 0, 0, 1, 1, 1, 0, 1. So these are all 8 bits. Okay, +29 is this. Since most significant bit is 0, so it is 0, and all bits, 7 bits, they represent the magnitude. Okay, so now this is +29. To have -29 in one's complement way, we will perform one's complement on this number. Okay, so one's complement is nothing but we complement every bit 1 to 0, 0 to 1. So then I'll be getting 1, 1, 1, 0, 0, 0, 1, 0. Okay, so now this is what -29 in one's complement method of representing negative number. Okay, so to have a negative number, first take its positive number, represent it in magnitude, and then complement it, then I'll be getting negative number. Am I clear?
Yes, ma'am.
So let us suppose now what is -31. So to have -31, first represent +31. How can I represent +31? 0, 0, 0, 1, 1, 1, 1, 1. This is +31, right? Now I want -31, so I have to take complement of it, one's complement of it. So I'll be getting 1, 1, 1, 0, 0, 0, 0, 0. Okay. So this is -31. Am I right?
Yes, ma'am.
Anybody have doubt here? See, if I want +31, it is 0, 0, 0, 1, 1, 1, 1, 1. Okay.
Ma'am,
Yes.
ma'am, in one's complement form, when we convert the negative numbers, for example, -31, back into decimal form, we won't get -31, no, ma'am.
No, we won't get. We won't get. We should not use directly the magnitude here, powers of 2. If you want back a decimal number, first you have to take its ones complement and then apply powers of 2. Since you have done ones complement, after getting the magnitude, you need to apply negative sign. That is the method. See, but whichever you are following, the same reverse method you need to use for conversion, right?
Yes, ma'am.
Okay. See, if any
Yeah.
number, let us suppose I have given a number. Let us suppose I am giving some number like 1. This is what my number. So what is its corresponding decimal number means, first you need to check the most significant bit. Since it is 1, so it means that it is a negative number. To get its corresponding value in decimal, first you have to complement this. And now apply the powers of 2, 2 power 0, 2 power 1, 2, 3, 2 power 4, 2 power 5. 32 plus 16, 48 plus 1, which is nothing but 49. So the value is 49. Since we got this magnitude after 1's complement, so that it says that my number is negative, so it is minus 49. So this number is nothing but minus 49. This procedure you have to use. Since I am saying that my number is represented in 1's complement form, hence I performed first complement. Why I have performed first 1's complement? Because my most significant bit is 1. Okay. And I'll be getting the number. This I need to apply the powers of 2 and then I apply the sign. Okay. Am I clear?
Yes, ma'am.
See, let us suppose my number now is 0, 1, 1, 1, 1, 1, 0, 0. So what is its value in decimal? Two power 6 plus, or else I can say from here, right? 2 power 7 minus these 2 is 3 minus 4 I have to go. 2 power 7 is 128 minus 4, 124. So how much is this? And my most significant bit is 0, so it is plus 124. Am I right?
Yes, ma'am.
Okay. Is that clear? This is the method that you have to follow for representing any number in 1's complement form. Okay. Now tell me what is the minimum and maximum values that I can represent in this. Minimum. So I have now both the positives and negatives. Minimum number. What is the minimum number?
MSB must
My
be 1.
MSB 1, all will be 1. No. So since we are complementing here, so it should be 1 and all other bits are zeros. Then this will be the minimum number. Okay. So because while calculating the magnitude, we have to complement this. And after applying the magnitude, we'll produce the sign. We'll apply the sign. So what is this value?
Minus 127.
Minus 127. And what is the maximum number? Maximum number.
0, all ones.
Positive and all ones. So which is nothing but how much? Plus
Plus 127.
127.
Ma'am.
Yes.
Then in this method also we are using the MSB bit to store the sign, no, ma'am?
Yes. In
Like
any case, in any universal notation is whatever it is the method that we follow, either sign, magnitude or 1's complement or 2's complement, universal notation, most significant bit, if it is 1, it represents the negative number. MSB bit 0, it is the positive number. See, even if you apply this procedure, check all the negative numbers have MSB 1 only. All positive numbers will have MSB 0. But the
Yes, ma'am.
advantage in 1's complement is, see, while operating, you no need to separate the sign bit here. Okay. We will treat all the 8 bits commonly and we perform the operation. But in case of sign magnitude, sign bit need to be separated and only the magnitude will apply, right? So, but here in 1's complement case, this is what the advantage over sign magnitude. We will consider all the bits, treat similarly as if like magnitude, and we apply powers of 2 to get the value. Am I clear? So first
Yes, ma'am.
disadvantage can be overcome in one's complement case, but the same remains same. Second disadvantage. What is plus 0? What is plus 0?
All
Positive.
zeros.
0, 0, 0, 0. Right? And what is minus 0?
1 and 7 zeros.
Minus 0. So first I have
All
to
ones,
take
ma'am.
2's complement. Kada? This is what? Minus 0. Right? Since my most significant bit is 1, so I have to take first 1's complement. So it will be all zeros. Then I will apply powers of 2 and then I apply sign. Okay. So this is minus 0 in case of 1's complement and plus 0 in case of 1's complement. Right. So even here, a 0 is 0 whether it is positive or negative, but there are two different representations. For 0, we have two representations. So hence, 1's complement method is also not suitable for computers. Am I clear?
Yes, ma'am.
Okay. Now we'll move to the third method, which is the efficient method, 2's complement. So how we do 2's complement? See, I want to represent minus 29. First, I will take plus 29 in 8-bit range. See, we are talking about only 8-bit range. So extending it to higher number of bits, we'll see later. In 8-bit range, plus 29 is 0, 0, 0, 1, 1, 1, 0, 1. This is plus 29. Now I want minus 29. So what should I do? First, I have to take 1's complement of it. 1, 1, 1. 0, 0, 0, 1, 0. And then I have to add a 1 to it, right? Add 1 to it. So then I'll be getting my actual minus 29. 1, 1, 1, 0, 0, 0, 1, 1. So this is your minus 29. Okay. See, here minus 29 is different. And here minus 29 is different. Okay. And even in sign magnitude, minus 29 is different. Okay. Am I clear? So it is need not necessary all will have same type of representation. So in 2's complement case, minus 29 is this value. Am I clear? Now move to next example. What can be minus 31? So first take plus 31. So plus 31 is 0, 0, 0, 1, 1, 1, 1, 1. 1, 2, 3, 4. Right? This is plus 31. I want minus 31. So first to take 1's complement of this. And now add 1 to it. So I'll be getting 1, 1, 1, 0, 0, 0, 0, 1. Okay. So this is minus 31. 1, 1, 1, 0, 0. Sorry. Yeah. 0, 0, 1. Minus 31. And what can be simple number? We'll take plus 9. Plus 9, 0, 0, 0, 0, 1, 0, 0, 1. Right? So even in here, MSB is 1 for negative case. MSB is 0 for positive numbers. Okay. So this is how we represent negative, whatever it is, negative or positive number in 2's complement way. Right? See, in any method, if the number is positive, you can go by direct representation, powers of 2. But if the number is negative, then only we have to choose out of sign or ones complement or two's complement form. Okay. So for negative numbers, we are talking mainly these three. Okay. So now under this, what is the minimum number that we can represent? Now tell. Minimum number. Since we are applying two's complement, so most significant obviously 1 and remaining zeros.
0.
Am I right? So with this, what is its corresponding value in decimal?
Ma'am, shouldn't the LSB bit be 1?
No. LSP bit 1. This is what the minimum number. See, apply complement. We'll check. First one's complement 0, 1, 1, 1, 1, 1, 1, 1. Right? And then add 1 to it. Now add all. See, 1, 1 is nothing but 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, and we'll be getting 1 here, right? So that is this thing. Okay. Same value is resulted. Now apply powers of 2. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Right? So how much is 2 power 7?
127, 128.
128. And we got this after 2's complement, right? So you need to apply negative symbol to the number. So what is this value? 100, 170 in 2's complement way is minus 128. Am I clear?
Yes, ma'am.
Now what is the maximum number? Maximum. This is obviously 0 and all will be 1. This is the maximum number. So what is its value? Plus 127. Am I correct? For
Ma'am, can you explain
maximum,
again, ma'am?
for maximum, we will go by positive numbers, right? So this bit should be 0 and remaining all will be 1. I'll be getting the maximum number. 0 plus 127. For maximum, we deal with positive numbers. For positive case, there is no concept of sign magnitude or 1's complement or 2's complement. Okay. All
Yes, ma'am.
positive numbers are same in any of the formats. Only for negative numbers, then the methods are different. Okay.
Okay, ma'am.
So maximum number is plus 127. In any case, it is same, plus 127 only maximum. Only the negative case, it varies. Right? So now what is the range of numbers that we can represent? Minus 128 to plus 127. Okay. So whatever all the disadvantages in sign magnitude form, where we have to treat the sign bit separately, here you no need to treat the sign bit separately. And the second disadvantage, zeros have 2 representations. Let us see whether here it is having 2 representations for 0 or not. So what is plus 0? 0, 0, 0, 0, 0, 0, 0, 0. Okay. So I want minus 0, right? So what should I need to take in 2's complement case? To get any negative number, first to take the positive number. So plus 0 తీసుకోవాలి. What is its value? Plus 0 is 8 zeros. And take 1's complement of it first. 1, 1, 1, 1, 1, 1, 1, 1. And now add 1 to it. Add 1. How much I am getting?
1 and 8 zeros.
0, 0, right? So we'll be getting extra carry, that is the 9th bit. Anyway, it will not be stored in the up to 8 bits, right? So that is extra carry. And anyway, in 2's complement addition, we will neglect the carry, right? If you remember. So these are the 8 bits, which are nothing but 8 zeros only. Okay. So for plus 0 is 8 zeros, and for minus 0 is also 8 zeros in 2's complement way. And you have to neglect the carry. While performing 2's complement additions, if you have a carry, you have to neglect, right? Okay. So this disadvantage is also overcome in 2's complement form. None of the number is having double representation. All are uniquely represented in 2's complement way. So this is the best method for representing negative numbers in computers. So this is followed in anywhere. Okay, any computers use 2's complement method of storing the numbers for negative case. Okay, am I clear?
Yes, ma'am.
Ma'am, in
Yes.
minimum thing, first we need to convert it one's complement number.
Yeah, this is what 1's complement value of this, and then I am adding 1, so I am getting this value, right? Same value I got.
No,
Now I have to apply powers of 2.
Yeah, I have doubt. Ma'am.
Tell me.
For minimum thing, we need to take maximum positive value. Ma'am. So we took 0 and all ones, ma'am. Then we need to apply one's complement. Then we need to add 1 more.
See, if we,
So we'll get.
you want to take all ones here, right?
Yes, ma'am.
See,
No. To get the minimum value, first we need to take zeros and all ones, ma'am.
0 and all ones. You want that
then we need
you are assuming that as a minimum number, right?
No, maximum number.
That only I have taken maximum.
Yeah.
Zeros and all
After
ones.
that, yeah, ma'am. After that, we need to convert into one's complement and then add.
No.
Add
For
one
positive case, since MSB is 0, we should not go by complement method. You need to directly apply powers of 2. For positive numbers, we won't go by complementing. Only negative numbers are complemented. If the most significant bit is 1, then you have to go by complementing and applying powers to get the corresponding number in decimal.
Okay.
For positive case, you don't need to go by this. Okay.
Okay.
See, I will make it more clear by representing all the numbers. See, for 8-bit, see, I'll be having numbers start with 8 zeros. Next, okay. Eight zeros, and next number will be 001. Likewise, it's not coming. 10, right? And next, what is the number? 00000011. Likewise, we will extend. This is 0, 1, 2, 3, and so on. I'll be getting maximum 1, 1, 1, 1, 1, 1, 1, 1. Okay, all ones. This is unsigned method where in decimal, the value is 0 and this value is 55. Okay. In unsigned case, this is unsigned. In unsigned case, all the numbers are treated as positive and all bits are participated in magnitude. So I'll be getting a range of numbers from 0 to 255 in decimal. In hexadecimal, because we usually go by hexadecimal ways, because representing this sequence of 8 bits is very complex, right? A very cumbersome process for with respect to humans. So we are going for hexadecimal way. In hexadecimal, we will group 4 bits together. This is 0, 0, right? 0, 0. And what is this? Grouping 4 bits together. This will be FFH, right? So in hexadecimal, the range is 0, 0 to FF. Okay. So here in decimal, range is 0 to 255. And in hexadecimal, the range is 0, 0 to FFH. This is H. So at the end, we apply H. Okay. Now, if I come for signed numbers, in case of signed numbers, the same 8-bit case, we'll be having both positives and negatives, right? So to have a first positive minimum, I start with 0, all 7 zeros. Okay. And positive. So this is 0, positive 0, plus 0. And to have plus 1, plus 2, and so on, up to, we'll be having plus 127, right? This is what the maximum number, plus 127. So I'll be having 0, 1, 1, 1, 4 ones. This is plus 127, likewise, plus 1, plus 2, plus 3, and so on, plus 127. In case of negative, I'll be having a negative minimum with 1. So negative is 1, minimum 1, 0, 0, 0, 0, 0, 0, 0. Okay. Negative maximum minus 0, 1. Sorry, sign magnitude we are talking about. So magnitude we need to take, no complement. Sorry, these will be all ones. So here, minus 0, 1, 0, 0. Okay. So this is minus 0. And this is minus 127. Right? What can be minus 1? Minus 1 name I will
1, 6 zeros, 1.
1, 0,
6
0,
zeros.
0, 0, 0, 0, 1. Likewise, 1, 0, 0, 0, 0, 1, 0. Like magnitude is same in both the cases. Only the sign bit will vary. Right? So this is,
Yes, ma'am.
in case of sign magnitude, we have plus 0 and minus 0, two different representations. Plus 127, minus 127 to plus 127 is range. Okay. So this is sign magnitude form. Because of this disadvantage, mainly, we won't go by this method. So we are going for ones complement. Sorry, I have to write it corresponding hexadecimal. What is its corresponding hexadecimal values? In hexadecimal, grouping 4 bits together, this is 7F, right? So 7FH. 7FH. And this is, what is this? FFH. Am I right? So this is in hexadecimal.
Yes, ma'am.
These are the range of values. 7F to FF to 7F. And this 0, 0, 0, and this is 8, 0. Okay. And this is 8, 1. Likewise, we'll be having 0, 0 to 7F. After that, 80, 81, 82, 83 till FF negative
FF.
values. Okay. Now come for ones complement. So in ones complement, positive numbers are same. In any case, the positive numbers are same even in the ones complement, because most significant is 0, remaining 7 bits only will participate in the magnitude, because 2 power, even if you apply for MSB, it is 0. So there is no magnitude added to the partial magnitude till 7 bits, right? So same numbers are for positive case. For negative case, it differs. Okay. See, if I want -0, start with -0. We know +0 is this. So you need to get complement of this, ones complement to get -0. So -0 is 8 ones. Okay. This is -0. Similarly, -1. You have to first take +1. +1 is 0, 0, 0, 0, 0, 0, 0, 1, and take one's complement of it. Sorry. One's complement of it will gives you -1. It is nothing but 1, 1, 1, 1, 1, 1, 1, 0 is -1. Okay. So likewise, if you extend, keeping the MSB 1, I may have a last number 1, 0, 0, 0, 0, 0, 0, 0. Okay, this is only the possible last number. Am I right? By reducing 1 from it, this is only the positive last number, which gives you, to get what is this value, I have to take a complement 1 with all 0 with all ones I'll be getting, which is nothing but -127. Okay. So now corresponding values in hexadecimal, this is FF. So -0 is FF, -1 is FE, and this is what? 80H. So these are the corresponding values in hexadecimal. Okay, only negative numbers will vary. So quickly we move to 2's complement and then we close. Time is running up. So 2's complement case, positive numbers are same. Okay, no difference. Coming to negative numbers, I want to represent -0. So to have -0, so first I should take a positive of it and then 2's complement it. First one's complement, all ones I'll be getting, add 1 to it, I'll be getting -0. See, whatever you have here, these numbers, if you add 1, I'll be getting the corresponding 2's complement addition. Okay. So put the -0. Then 1 add just I'll be getting all zeros. 0, 0, 0, 0, 0, 0, 0, 0. This is -0. What is -1? So first this is +1, take 1's complement and then add 1 to it. So if I take 1's complement, this is the value, you need to add 1 to it. I'll be getting 7 ones. Sorry, 8 ones. This is -1. Likewise, -2, 1, 1, 1, 1, 1, 1, 1, 0. So if we extend, there is a possibility of last minimum number with 1, 0, 0, 0, 0, 0, 0. This is only the last minimum number. So which is nothing but -128 here. This is not +1, -127. Okay. What is -127? -127 is 1, 0, 0, 0, 0, 0, 0, 1. This is -127. Okay. Am I clear? I have to add 1 to it to get this value, right?
Yes, ma'am.
Okay. So corresponding numbers in hexadecimal. This is 0, 0. -0 or +0, both are same. So it is 0, 0. And this is FF. FF is nothing but -1. And this is 80. 80 is -128. Light white, 81, 82. So if the magnitude is going in this way, the negative number is increasing. 0, 0 to 7. Okay. So this is 2's complement way of representing. See, these are very, very important to practice. Okay. So if I say a number like, let us suppose my number is AB. Can anybody say ABH? What is this number, positive or negative? ABH. It is very simple.
Negative.
See, A is nothing but 1010. B is 1011. Most significant bit is 1. So it is negative number. Numbers fall from 80 to FF are negatives. This will be in this range. AB is in this range. Numbers from 00 to 7F, okay, are positives. Okay, right? Likewise, we calculate the negative numbers are represented in computers in this way. So 2's complement method is the best way to represent, and it is followed by universally all computers uses this method only. Okay, that's all for today. So next class we go with what is fixed point representation first of all. So we started with only representing negative numbers, and what is fixed point representation, then we'll see next class. Okay, so let me stop share. See, all the numbers are in serial only. Okay, I'll take the attendance quickly. Please wait. Hmm. 62 absent. 65 absent. 67 absent.
65 present, ma'am.
Present. Well, you need to change your numbers, ma, because I will see the participant list and take the attendance. Okay. So in this way, you have to change your name. 67 absent, 72 absent, 76 absent, 78 absent, 80 absent, 82, 90, 93, 96, 100, 102, 113, 117, 120. That's all. Okay, absent is 62, 67, 72, 76, 78, 80, 82, 90, 93, 96, 100, 102, 113, 117, 120. Okay. Thank you, Amma. Sorry for the delay. You can proceed for next class.